Hello and welcome everyone. This is MrSovr with another Minecraft tutorial video. I am going to be going over a lot of the redstone and Technic, and right here, as you can see, I got a huge setup running right now. I'm going to go over each redstone piece. I believe this is from Red Power, I believe. I don't know, I could be wrong on that part, but I'm mainly here to tell you how these things work. Now, the very first thing here is a timer. Now, of course, or a clock, either one. Of course, everyone that has played Minecraft for a while may understand all this stuff, but for those of you who don't, this is how it works. It basically creates a sort of a bit like a pulse, a redstone power every certain amount of time. And the best thing about the Technic version, that bird in the background is really annoying. The best thing about the Technic version is that you can right click on it and you can specifically say how many seconds of a delay before it does another pulse. So for example, I can make it go really fast or really slow. Now that's the plus side of the timer, and timers are usually used for I don't know, sequential logic, basically, if I've gotten that right. I don't know, it's been a while since I've taken electronics class, but it's basically where it's usually for clocks, like actual clocks, like timers, binary counters, stuff like that is usually for timers. Also memory, stuff like that. Right here is a sequencer. Sequencer is sort of similar to a timer, but it has like based on where this thing goes, it will select which side of the block to turn on. So again, if we make this really quick, it selects all the different ones around it. Now, of course, these blocks are lamps, so if you were to break this and have redstone, it would do that too. So it doesn't really matter on that part. I just have the lamps to display how this works and stuff like that. So that's how the sequencer works, and that's how the timer works. When we go over here, there's a thing called a state cell. Now, when I turn on this lever, which is going to send redstone signal to this side right here, it will turn on the state cell, which is supposedly that, and then as soon as I take away the power, this thing starts moving until it hits the very edge there and then resets it. And I'm going to show you that right now. So it turns on, everything alright, then we turn it off and it stays on for a certain amount of time and then it shuts off. Of course, we can go into here and we can increase the time to, for example, from 2 seconds to 12 seconds. And as you can see, it'll go for 12 seconds, which is a lot longer than the 2 seconds I just showed you. And as soon as it's up, there you go. That's how that works. Right now, these are, excuse me, these are all logical gates, more than just things like that. A few of them are combination logical gates, and I also have a randomizer at the very end, which I'll go over. Right here is the NOT gate. The NOT gate is an inverter. So if there's nothing going into it, or an off state of redstone, there's an output of an on state of redstone. So of course, if I break this, it'll also demonstrate that the power is actually on. Now when I switch this, the power output is off. It inverts the input and it has the output. If there's on going in, there's off going out. If there's off going in, there's on going out. Of course, the way you can determine if there's an input is when there's nothing going here. There are technically, I believe, yes, more than one output. For, I don't know, probably simplicity, make it a little easier for people to work with, so you don't have to have 3 inverters, instead you could just have 1. But, of course, there are 3 outputs and 1 input, and if you have, of course, nothing there, you can tell where the outputs are because they'll all be on. Okay, so now we go over here to the AND gate. Now, when I say AND, that means that all the inputs have to be on in order for the output to be on. So I can have all these off and this off. I can have this middle one on and this one off. I can have this one on that will still stay off. And of course I can have this one on, and this one will stay off. I can even have a combination of these on, except for one, and this will still be off. And I can also show you it right here. As you can see, all the combinations, as long as one of them are off, the output's off until all of them are on. So let's just say for scenario-wise in Minecraft, you have 3 pressure plates. You need all 3, let's just say you have a party of people going through a adventure world. And you need a mechanism to say, okay, you need to be on this pressure plate, that pressure plate, and the 3rd pressure plate in order to open up the doors, or piston doors, something like that. So you would use an AND gate for that function. Let's just say person A is on pressure plate A, person B is on pressure plate B, but person C is not on there and still trying to get there. The door will not open until the 3rd person's on the pressure plate. Of course, these are levers, not pressure plates, but they're the same concept. So when we go over here, it's a little bit different. It is what we call a NAND gate. A NAND gate is basically exact same thing as an AND gate, but has the opposite outcome. For example, you can have, as long as you keep one off, you can have as many of them on, and it will be an on output. You can just have one, you can have these 2, you can just have that one, but you need all of them on to have an output of 0 or off. Of course, when I associate 0 and 1 with these tutorials, 0 means that there is no current, or not, well, I don't want to get into currents with redstone, but there's no power going to whatever device you are powering. And when there's for example, this would be a 0, this will be a 1. This is off, that is on. That's what I mean by 1 and 0. And we will get into binary eventually, which actually we kind of will a little bit down the ways. Of course, all these Mo creature pieces of crap are in the way, but oh well. But you kind of get the concept. As long as you get the concept of the inverter, AND gate, NAND gate, you're pretty much pretty good with a lot of this stuff. You'll probably understand it a lot. Now, I believe this is an XNOR. Am I correct? Yes, okay. So, an XNOR is a little interesting, and the way that's spelled out is NXOR. It's like an OR gate, but it's an exclusive OR gate. Now, an exclusive OR gate basically looks for differences within its inputs. For example, well, actually, this is equality. An XOR is for differences. So, both of the inputs have to be the same in order... Oh, wait. Okay. Just double checking. Both of the inputs have to be the same in order for this to turn on. So, if you have one off, or one on and one off, it'll turn off. If you have both of them on, then it'll turn on. But if both of them are off, that will turn on. But of course, you cannot have one off, one on at any time. You must have both of them off or both of them on. It's basically, if you are a programmer, which I don't know how many of you are, this is like an if statement, but it's for 2 inputs of redstone. If both of them are on or if both of them are off, then it's turned on. But if one is different than the other, then turn it off. Well, I guess you can consider other things if statements. But if you don't understand what I'm talking about, don't really worry about that part. Just know that if you have both ons, that turns on. If you have both off, that turns on. But in other cases, it will be off. Okay, so now that we've I believe there are other logical gates, which I guess I should probably talk about them. There are other gates like OR gates and NOR gates. OR gates is basically this. Now I know there's an actual gate for it, but this will best demonstrate what an OR gate is. It's either if this input is on, that's on. If this input is on, that is on. If both of them are on, that is on. The only time an OR gate is off is when both inputs are 0. In other cases, as long as one of the inputs are on, the output is on. And a NOR gate is just simply an inverter at the very end of it. I guess I might as well show that too. So we have our redstone, we have our block. This is like a vanilla version of an inverter or a NOT gate. So as you can see, it turns on as soon as both of these are off. It turns off as soon as there's an input that is on. It doesn't matter which one or if both. As long as there's an input on, it turns off. But if there's both off, if both inputs are off, then this is on. I know for newcomers to logical gates and stuff like that can get a little confusing. You might have to watch this a couple times. I know when I first started, I kind of did. But anyways, moving on here. This is what you may call an I almost said something, but RS latch. Now, what exactly is a latch? Well, latches are usually can be looked at as a form of memory. Usually there are like two logical gates put together to have a certain function. It's also similar to flip-flops, but they're a little bit different. Now, I don't know the details totally, as I do not remember them exactly. All I just know is how this thing functions, and that's all that really matters at the moment. So since this thing is a memory source, I can technically take this away, and this thing will stay on. As you can see, there's no power source getting to it. It just acts as a memory source by itself. Whoops. Now, of course, if we were to look at this in a real-life scenario, there would technically be power going to the circuit. It's just that the inputs and outputs are, well, the outputs are putting out power as long as that RS latch, that side of it is actually had power going to it, switching it to turning it on. I don't know, it's kind of hard to explain. Let me just show you. So if I were to turn this on, now that side has memory, and this side reset itself. So the main way that you would use to store, let me just make sure this is it. No, it isn't. The main, an application that you can use by using the, dang it, where is it? By using the latches, or by doing this. You would have a magnitude of these, like this. Now, I don't know if this would actually work. I need to test this out. I wasn't really planning for this for the video, but if I am correct... Okay, good. So if I were to move these like this, I can program this as a form of memory. The only problem is I have to reset this. Oh crap, it doesn't work. Okay, never mind. I'm sorry. I'm really sorry. I didn't rehearse for that. But anyways, moving on. Oh man. But anyways, here is a adder circuit, which is a combination of an XOR and an AND gate, and of course a repeater because it can't reach that far. Now, if you know anything about binary, this will be great for you because this is how you add binary numbers. The only problem is this is only for a bit. If you have 2 bits, for example, if you don't know what binary is, it is a counting system or a numerical system that only has a 1 and a 0, none of the other numbers in it. You can count in binary, you can do addition, subtraction, multiplication, dividing in binary. If you couldn't, your computers couldn't do anything because they run off of binary. Now what's great about binary is that it's either an on or an off. For example, as I told you before, the 1 and the 0. This is where binary comes in. So 1 plus 1 in binary is equal to what? 10. And, well, yes, it does. Okay. Almost scared myself that I did it wrong. But anyways, 1 plus 1 equals 10. 1 plus 1 plus 1 equals 11. So it goes like 1, 10, 11, 100, 101, 110, 111. That's basically how you count in binary. So we think to ourselves, okay, well, here are 2-bit inputs. So what in the heck are these outputs? This is the sum output, and this is the carrier. You know, if you do addition, like by hand. Let's just say you have 5 plus 6. Well, that equals 11. But you have a 1, and then you have to carry your 1 over to make 11 into the next spot. Now, if you don't know that, then apparently you did not go to the school. But anyways, moving on, that's the basic idea of what this is. This is the carrier, and this is the sum. The sum is the holder place of which these inputs are. So, for example, this is the 1 spot. Not the 10, not the 1, not the 10, not the 100, not the 1,000. This is the 1 spot. This is the 10 spot. So if we have both of these on, 1 plus 1 equals 10. That 1 has to be carried over, and there's a 0 in the sum spot. So let's look at this. Okay, so here's the 1 spot. It's a 0, and here's the carrier. This is a 1. So this is 10, if you look at it. Like, here's a 1, here's a 0. That's 10. Here's a 1, and here's a 1. 1 plus 1 equals 10 in binary. And that's basically how that works. And the way that you would actually continue this is going to be in the next video, but the carrier would go into a full adder. This is just a half adder. It's usually like the starting point of your adding system. And from here, you can add this circuit over and over and over and over again for like 8-bit, 16-bit, 32-bit, 64-bit. And it's really amazing what you can do with adders. And there's subtractors and multipliers and shift registers and all sorts of that fun stuff, which I'll get to sooner or later. Now, this is really quick. The randomizer, very straightforward. You put a redstone torch in the back of it, and it randomly picks which side to change. That's all it really is. And the only way that you can control the randomizing picking is if you add a timer here. Because as you can see, oh wait, if I put it down and change it quickly, even though it's not looking right, it keeps its state. So you can always just do a timer, and as soon as the timer clicks, it changes its decision on which side to put out an output, and then it'll delay for how long you want. And that concludes the Technic version of Redstone tutorial, and thank you for watching. Make sure to leave a like, subscribe, definitely subscribe, please. Leave some comments if you have some suggestions, or if you have any questions, I'll surely answer them. And if you want, make sure to share the video, which I always appreciate, because I'm sure that someone else will have problems with these, and I'm more than happy to help them through these videos. Of course, this is MrSovr. Thank you for watching. See you later, and subscribe. See ya.